Multi-touch interactions are a promising means of control for interactive tabletops. However, a lack of precision and tactile feedback makes multi-touch controls a poor fit for tasks where precision and feedback are crucial, such as media editing and graphic design. We present an approach that offers precise control and kinesthetic feedback for tabletop systems through the integration of physical controllers with the multi-touch environment. These controllers can be distributed among co-located users, addressing issues such as reach and territoriality. Our approach is appropriate for a range of cooperative scenarios where the shared visibility and direct touch interaction of a large multi-touch tabletop offer collaborative benefits, but where precise control over many parameters is necessary. In this video, we illustrate these interactions in the context of our collaborative audio editing prototype, Ensemble, which embodies these interface design ideas. It is possible to interact with Ensemble using only multi-touch gestures on a centralized editor, which contains virtual controls for a small set of common continuous and discrete audio editing parameters, such as volume, mute, and playback, as well as parameters controlling the editor display itself. In the physical world, sliders and knobs are familiar devices for controlling continuous parameters. However, the limits of touch sensing precision and a lack of kinesthetic feedback make these virtual controls considerably harder to use than their physical counterparts. So users may employ the centralized touch controls when they are within reach and when the edits are not too fine-grained, maintaining the benefits of a collaborative shared editing area. In situations where the touch-sensitive surface offers insufficient precision, users may employ real knobs and buttons on any of several physical controllers integrated into the system. Each controller box is individually recognized and tracked by the table, so it can be placed anywhere. Giving 1 or 2 boxes to each person allows for repositionable, user-specific control areas. Surrounding the box are virtual representations of the editing parameters, if any, that are controlled by each knob and button. At any time, a user can change the mapping between the controller and the editing parameters. He is able to copy any of the available parameters, both editing parameters and display parameters such as zoom, from the central editor to the controller that initiated the copy. Once selected, these parameters are copied to a clipboard associated with the physical controller, and the user can place controls from the clipboard into the control box, mapping discrete parameters to physical buttons and continuous parameters to physical knobs. The display around the controller box provides a label for each control, as well as local visual feedback as that control is changed. The central editor and any other physical controllers mapped to the same parameter will also provide visual feedback as the parameter is changed. A user is able to execute a query to identify all points of control for a parameter. The display surrounding each control box is also touch-enabled, so the user has the option of interacting with local controls via either the physical controller or the virtual widgets. The user can obtain copies of new controls at any time. Ensemble also supports saving the current mapping and reloading it later, either to the same controller box or to a different controller box. We observed 10 groups of users performing collaborative editing tasks with the Ensemble system. Our observations suggest that integrating remappable physical controllers into co-located tabletop groupware does increase precision and feedback. And furthermore, users engage the flexibility of the system to support a variety of group interaction styles and editing strategies.